In this video, I want to look at example 5 from the FDWK book, section 3.4. And we're studying particle motion. A particle moves along a line, and in general, we're going to consider this to be the x-axis. So that its position at any time t greater than or equal to 0 is given by the function s of t is equal to t squared minus 4t plus 3. And often you will see in different problems of this type that the function is also called x of t. So its x position, or its position along the x-axis, is a function of time. And for every particular point in time, the particle is at one and only one place, one point along the x-axis. And its position is defined by that particular function. And where s is measured in meters and t is measured in seconds. So we want to find the displacement of the particle during the first 2 seconds. Now displacement is just the position or the distance between the starting and ending point of a time interval. And it might either be to the right, then it would be positive, or it would be to the left of the starting point. And since we're looking for the displacement of the particle during the first 2 seconds, we're going to take s of 2 minus s of 0. And s of 2 would be 2 squared minus 4 times 2 plus 3, minus s of 0, which I put in parentheses to make sure we get our signs right. And now I write all that out, but actually it's much simpler than that because s of 0 is just 3. And s of 2 is 4 minus 8, which is negative 4, plus 3, which is negative 1. And so we have negative 1 minus 3, and we end up with a displacement of negative 4 meters. Again, let's try to make some sense of what that means. I drew a little number line there, and we know that at time t equals 0, the particle is at position 3. And at t equals 2, the particle is at position negative 1. And from that, we can see that the displacement, or the total change in position between time t equals 0 and time t equals 2 is negative 4 meters. To find the average velocity of the particle during the first 4 seconds, we're just going to take the slope of the line connecting the points when t is equal to 4 and t is equal to 0. So the average rate of change, or the average velocity in this case, is the slope of the secant line connecting the beginning and the ending points. And I won't go through all the calculations this time, but s of 4 is just 3, and s of 0 is also 3. And since the particle started at position 3 at time t equals 0, and it ended up at position 3 when t equals 4, so the average velocity over the first 4 seconds is just 0 meters per second. There was no displacement. Remember, average velocity is total distance traveled, or it's the displacement, rather, divided by the time it took to get there. That would give you your average velocity. And in this case, it's 0. Alright, to find the instantaneous velocity of the particle when t is equal to 4. Well, if the position is t squared minus 4t plus 3, then the velocity is s prime of t, which is 2t minus 4. And so v of 4 would be 2 times 4 minus 4, which would be 4. And so the instantaneous velocity of the particle when t equals 4 will be 4 meters per second. To find the acceleration of the particle when t equals 4, well, the acceleration of the particle is the derivative of velocity, or the second derivative of position. And that's going to turn out to just be 2. Since the velocity was 2t minus 4, the derivative of that will just be 2. And that tells us that the acceleration is constant. It will be 2 at every point in time. And finally, we want to describe the motion of the particle. And we want to answer the question, at what values of t does the particle change directions? The particle changes directions when the velocity is 0. Well, it doesn't necessarily change directions, but the velocity has to be 0 when it does change directions. It actually changes directions when the velocity changes from positive to negative, or negative to positive, which can only happen at 0. So it changes directions at t equals 2. And my answer is there.